Hi everyone. So the next operation is cross product operation. In cross product operation, let us suppose we have two languages L1 which have D1 as a DFA and language L2 which have D2 as a DFA. If I cross product L1 cross L2, then we get D1 cross D2 as the resultant DFA. Okay, so what I mean to say, let us take an example. Let's say a language which contain even number of A's, okay, and even number of B's. Okay. So as usual, first I will draw the transition diagram for even number of A's, and then after that I will draw the transition diagram of even number of B's, and finally I will merge these two transition diagrams and make the whole picture. Assume that the sigma is A comma B. So in all the examples we have discussed so far, the sigma is A comma B, means input alphabet is A and B. So if you draw DFA for even number of A's, then you will get the transition diagram, capital A as the initial state. Why I always take capital A, capital B as a state number? You can take any random letter or a particular, say, random alphabet as a state. It doesn't matter. The only matter is how can you draw the transition diagram of the particular language, and it will be meaningful. Means if you draw the minimal DFA, then it will be more meaningful and you can easily visualize the language. Okay, for even number of A's, let us say I have take capital A as an initial state. If I see a small a, then I will go to the capital B state. Okay, and if I see one more small a, that means I see two A's which is even. So here I will take small a in the loop. So on capital B, if I see A, I will go back to the initial state capital A, and it means that we have seen two A's so far, and this process will repeat further. Okay, so it means that capital A will be the initial state as well as final state, and capital B is non-final state. Capital A is the initial as well as final state, capital B is the non-final state. Okay, and what about the symbol B? So if I see B, then I will remain in the state capital A itself, and if I see here A, here small b, then I will remain in the capital B itself. So this is the transition diagram for even number of A's. Now draw the transition diagram of even number of B's. Let's say capital C is the initial state here, and if I see small b, then I will go to the capital D state. If I see one more small b, I will take it in the loop part and goes to the initial state itself. So capital C is the final state, and here I can accept any number of A's, and here also I can accept any number of A's. Okay, so this is the transition diagram for even number of B's, and this is the transition diagram for even number of A's. Now what I will do here is I will merge these two transition diagram. So you will think that I can join this transition diagram from here or from here, but it is not true. It is true in the union and concatenation part, but it is not true in the cross product operation. So in cross product operation, you can easily visualize this transition diagram and make a final transition diagram of the language. So here capital A and here capital C. So there are total 4 states possible in the final transition diagram. How? If you cross product these two DFAs, so there are total 4 states: AB cross CD. So the number of possible states will be AB is the first state, then AC second state, AC first state, then AD second state, then BC third state, and finally BD fourth state. So there are total 4 states possible. So considering the first state AC, if you see A, small a, so capital A on state capital A, if you see small a, then you will go to the state capital B. So here capital B. And on capital C state, if you see A, then you will remain in the C state itself. So AC state on seeing small a will go to the BC state. Similarly, you can draw all the parts also. If you present at state number AC and seeing a small symbol B, so on A seeing a small b will remain in the A state itself, and on a small b I will go to the capital D itself. So AC on seeing a small symbol B will go to the state AD. So here I can easily draw the transition diagram. AC, then AC after then AD, here BC, and here BD. And on these 4 states, which state is the final state? So if you look back to the previous diagram, here the final state is capital A and here the final state is capital C. So in this final diagram, the final state is capital AC, and capital AC on C small a will go to the state capital BC. Okay, so I will draw the transition diagram because I know the answer. I already draw it once again. Here B, here A, B, here A, here A, here B, here B. You can check it via this particular method. So you will get the final transition diagram. Okay, so this is the transition diagram for language which have even number of A's and even number of B's. So I think you understand the cross product operation. In cross product operation, if a language contain, let's say, n state and other language contain m states, then the final language, when you apply cross product on them, the final language will contain n cross m states. Okay, n cross m number of states. Okay, so in the next video we will see the complementation operation on deterministic finite automata.